Hi everyone, welcome back to Samaliaki YouTube channel. I'm Sir Joseph and today we are diving into an exciting thermodynamic tutorial question. Whether you are a student preparing for exam or just curious about thermodynamics, this video will help you understand key concepts and solve problem effectively. This is our first tutorial and the question number 1 states that in an open beaker at 25 degrees Celsius and a 1 atm pressure, 100 grams of zinc are caused to react with dilute sulfuric acid. Calculate the work done by hydrogen gas, assuming it to behave ideally. What will be the work done if the reactant took place in a sealed vessel? We have been provided with the temperature of 25 degrees Celsius, which is equal to 298.15 Kelvin, the pressure of 1 atm, and the mass of zinc is 100 grams, and we are required to find the work done by hydrogen gas in an open system as well as work done by hydrogen gas in a sealed vessel. Let us consider the reaction equation below. We have zinc which reacted with the dilute sulfuric acid to form zinc sulfate and the hydrogen gas. We can see that for each mole of zinc reacted, then 1 mole of hydrogen gas is produced. Now, how many number of mole of hydrogen gas will be produced when 100 grams of zinc reacted? We know that number of mole is equal to mass over molar mass, but since we are dealing with a zinc, it will be the number of mole of zinc is equal to mass of zinc over molar mass of zinc, which is equal to 100 grams, and the molar mass of zinc is 65.39 grams per mole. Here we can get the number of mole of zinc, which will be equal to 1.529 mole. But in our equation, the mole ratio of zinc and hydrogen is 1:1. Therefore, the number of mole of zinc, which is equal to 1.529, will be equal to number of mole of hydrogen gas. After having the number of mole of hydrogen gas, now the work done in an open system is given as the product of pressure and the volume, which is equal to nRT. This is because we have been told that our gas obey an ideal gas equation. Because they said that it behave ideally, it means it obey the ideal gas equation. Now remember that when the system does a work, you have to include a negative sign. So our work done will have a negative sign showing that the work is done by the system. Now our work done will be equal to that number of mole, that is 1.529 times R, that is universal gas constant, is 8.314, times our temperature is 298.15. You'll get our work done, which is equal to negative 3.79 kilojoule. Therefore, the work done by an open system is negative 3.79 kilojoule. But also we have been told that to find the work done by hydrogen gas in a sealed vessel. Now, the work done in a sealed vessel, we know that work done is equal to a P change in Vp for pressure and the V for volume. But in a sealed vessel, change in V is equal to to 0. Since our change in volume is 0, the work done in a sealed vessel is equal to 0. Here is our question number 2, which states that a chemical reaction occurs at 300 Kelvin in a gas mixture that behaves ideally, and the total amount of gas increases by 0.27 mole. If the change in internal energy is 9.4 kilojoule, what is the enthalpy change? We have our data here, and we know that a system initially contained n moles. Now, when the reaction has occurred, an extra 0.27 mole has been formed. So the extra 0.27 mole have caused a change in PV, and since the temperature remains constant, the relationship is change in PV is equal to change in number of mole times R, that is universal gas constant, times temperature. Now, on substituting the value of N, R, and T, you can obtain the change in PV, which will be equal to 673.4745 joule, which is equivalent to 0.6735 kilojoule. Now, we are looking for the enthalpy change. We have been told to find the enthalpy change. Now, from the meaning of enthalpy, thus enthalpy is the property of thermodynamic system, and it is defined as the sum of internal energy and the product of its pressure and volume. That is, change in enthalpy is equal to change in internal energy plus change in PV. Therefore, change in enthalpy is equal to change in internal energy is 9.4 kilojoule plus change in PV is 0.6735 kilojoule. So our enthalpy change will be equal to 10.07 kilojoule. This is our third question, and the question states that from the following enthalpies of reaction, calculate the enthalpy change for the reaction of ethylene with fluorine. Over here, to solve the value of standard change of enthalpy, we need to find the exact reaction by simple manipulation of the given reaction. And remember that if the reaction is reversed, also its enthalpy change will be reversed. That is, if it is positive and we reverse its equation, also the value of enthalpy change will be negative. And if it is negative, we reverse its equation, the value of enthalpy change will be positive. Also, if you multiply the equation by any factor, also the enthalpy change value will be multiplied by that factor. Now, consider those given equation. We have three equations, but also we have the general equation that we are looking for. But in order to get this equation, we see that ethylene in our given equation is on the reactant side, but in the equation 3, the ethylene is in the product side. So we have to reverse the equation number 3 so that we can have the general equation. So on reversing equation 3, we get something like this, and we can see that its enthalpy change became negative 52.3 kilojoule. Also, we have to multiply equation 1 and 2 by 2. That is, equation 1 and 2 have been multiplied by factor 2. And also in their enthalpy change will be multiplied by 2. Now on summing those three equations to get our required equation, the carbon and the carbon will goes out, hydrogen and hydrogen also will cancel out. Therefore, the reaction with the desired enthalpy change is given as this one. Since we have summed the equation to get our final equation, also the enthalpy change for our final equation will be the summation of the enthalpy change of these three equations. Now on summing all the enthalpy change, we will get the enthalpy change for our required equation. Thanks for watching. If you found this video helpful, please give it a thumb, for consider subscribing to Sam Aliaki YouTube channel and for more tutorial. If you have any question or suggestion for future topic, leave them in a comment below. See you next time.